Hey guys, here I am again, come from Jack's room still. Anyway, I'm going to do a quick reteach of writing the function rules all the way through graphing again. I need you to have a piece of graph paper, pencil, and something to draw straight lines with, whether that be a ruler or something, another pencil, whatever. I'm going to present my screen so you can see what's going on. It, again, just takes me a minute. So just give me a second to get there, and let me go over to the problem. Okay. So here we are. The yearbook club makes $25 per page of advertising in the yearbook. So this will be more like your Ledyard High School yearbook, or if you go to a different high school, the books are pretty chunky. So they cut the cost to the student by selling advertising. So $25 in this case per page if you're going to buy some advertising in the yearbook. So we're going to write a function rule to model this situation and to make a graph. So the first thing we need to talk about is sort of what are the two unknowns here. So the first one would be how many pages, and the second one would be what? The cost, right? So now which one is independent and which one is dependent? Which one is your choice here, right? You are going to choose how many pages. So the independent variable, I'm going to call it X in this case, would be the number of pages. The dependent variable is waiting for the math to happen. And what depends on the number of pages? Did you think the dollars made, right? The dollars that the yearbook is going to bring in from the advertising. And I said dollars there, so I didn't have to put the little dollar sign. Okay, so now we have to relate the variables. We need to talk about that the dollars made is $25 per page. So if you buy one page, it would be 25, two would be 50, three would be 75. This is actually just a one step here. So it's just the output, the Y, would equal 25 times the input, the X. There's our function rule. Now, before we move on, will this data representing the pages of advertising be discrete or continuous? And once you have your answer, can you explain why? So I immediately think, does it jump? Is somebody going to make is somebody going to buy 1.267 of a page? And the answer is no. You're going to buy one or two or three. So this would actually be a discrete because you can't purchase fractions of a page. Now, having just said that, I think the Ledyard High School actually allows you, I think the smallest is like a quarter of a page, but that's a different problem. All right, so let me go ahead and put this up here. There's our rule. So the next thing we're going to do is create a table. So what's reasonable inputs here? Now you know that the first one I'm going to put in is 0. This is sort of, that doesn't make sense. You're not going to buy 0 pages advertising. But again, it's going to anchor the graph. So if I take 25 times 0, it's 0. So think about pages. Am I going to buy 100 pages of advertising? No. More than likely, I'm going to buy 1, 2, and you're going to notice I'm kind of going up to maybe 6 or something like that. All right, so 1 times 25, that 25 times 2, the 25 times 4, the 25 times 6. So that's how we start. We write the function rule, we define our variables, and we make a table of values that makes sense for this problem. So, we're not putting negatives in. We're not putting fractions in. We got a title on our graph. So this is kind of where you're going to head over to the graph paper. And let's get, if you could, draw a Y and an X-axis. We're only using the quadrant 1, so we don't need quadrants 2, 3, and 4 because we're not going to be dealing with negatives. Get a title on there, and the first thing you're going to do is give a little space, and we're going to put our labels. And the labels are really easy because they're the definition. So X is going to be the number of pages, and Y is going to be your dollars made. So let's write those and leave a little space because you're going to have to put the numbers in. Okay. So now we have to kind of decide on a scale. And I want you to think about it. Now look over here. you know, we're going 0, 1, 2, 3, 4, 6, you know, there's not like 100. So we really just need to get up to 6. And so what you'll see I'm doing is I'm doing like every 2 blocks is 1. And then 2 more blocks would be 2. And 2 more blocks would be 3. Why don't you make that same scale to kind of match mine? So we could go out to, looks like 7. We could get out to about 8 here. And I'm being patient. So you should have a title, you should have your labels, and you should have put in those numbers for the numbers of pages. Now, before I go over here, I need to look at what's happening. I need to get up to 150. 1 sure isn't going to work. 2s aren't going to work. I don't even think 5s are going to work, you know, so I need a scale that each block will get me up to 150, but I don't want 150 to end up like down here. I want to spread it as much as I can, but still fit. So I am doing, so if we look, this would be 25. So 2 blocks is 25. This is what I picked. And that gets me, that uses most of the graph paper. So 25, 50, 2 more blocks would be 75, 2 more blocks would be 100, 2 more blocks would be 125, 2 more blocks would be 150, and 2 more blocks would be 175, and then up to the 200. You are welcome to write those numbers in between if that helps you plot the points, but you don't actually have to. So the next job is to plot the points. So we're going to get our, and make it a little bit bigger here. So I'm waiting for you to kind of get caught up with me, and I'm getting ready to plot the points. That's a huge point. This is what it looks like. Get a little smaller. Okay, that'll work. All right, so 0, 0. And then I go 1, 25. We're going to go 2, 50. We're going to go 4, 100. And it looks like I put the 100 down. Let's see, yep, it's right up here. Sorry. I had to make sure I was in the right spot. And 6 would be 150. And my point should fall in the line. And I'm looking a little bit worried there. So is that right? So 50, 75, 100. And that's 4. And then 6. So we would go 3, 4, 5. I'm just checking my points. And then we're going to draw in our line. So look like I had one off there. There we go. All right, our line isn't a line, it's a ray. Arrow on one end, not on the other set. And you could do 8, you could do 9, you could do so forth, okay? So now use the graph. So we're going to look on the graph to find out how many pages would cost $175. So $175 would be right here. And I'm going to ride that line out until I get to my graph, which is right there. Whoops. Let me just put that point there. Sorry. And then I'm going to come down, and you'll notice it would be 7 pages. So I can use the graph to make a prediction. Well, wait a minute, Mrs. Hurd. If you said that this one was going to be discrete, so why did we draw that ray in? And it's for the exact reason I just said. Is you would have to put all the dots in. By putting a line, I can go out and make a prediction. So even though this is a discrete graph, I did put that line in this case, array, so that I can do what I just did and make a prediction. Now use the function rule to determine the cost of 11 pages. So notice my graph doesn't go out to 11, so I can't use the graph, but I could go back and kind of make 11 my input and take 25 times 11, and that would also be another way to make a prediction. In that case, it would be $275. So if you are using the graph, you kind of have to show me what's even better than just kind of sticking the dot there, is you could kind of make a ring of where the point is on the line and kind of show me that that's where you're making the prediction for the 175. That was the 7 pages. But if your question is off the graph, that's where the function rule comes in, and you can use that. Okay, let's do one more together before you practice again yourself. So let's imagine that you have a full hot tub. It contains 266 gallons, and you can drain the tub when you pull out the plug. 9.5 gallons leave leave the hot tub per minute. So after 1 minute, you got 9.5 gallons out of the tub. After 2, it would be 9.5 times 2 gallons out, 9.5 times 3 after 3 minutes, or leaving the tub. Define variables and write a function rule to model this situation. Now, we've been using X and Y. In this case, I am going to use 2 other variables, not to confuse you, but science does it to us all the time. And sometimes kids get so hooked into X and Y that they have a hard time kind of changing over. So this one, I am going to use different variables just to practice, okay? So we have, the tub, and we have minutes going on, and we have gallons in the tub. Those are really the 2 things that are happening here. As minutes go by, what happens to the water in the tub? And you should be saying it's going down. So what depends on what? Does how many gallons are in the tub depend on how many minutes have gone by? Or does the clock somehow miraculously change based on your hot tub? Well, that's kind of crazy. So it's the minutes. And if time are involved, they are usually your independent variable. And this time, instead of X, I'm going to use M for minutes. But if you want to put a little X out there, that is our independent. So we decide how much time the plug is out of the tub, basically, how many minutes. So therefore, the gallons left in the tub would be our Y, or our dependent variable. We're now going to write an equation that's going to have the G, the M, the 266, and the 9.5. Remember that your dependent variable is waiting for the math to happen. So we put him in, and now we've got to connect to these numbers. So does the 266, that's started, that's our start amount. What is happening is the 9.5 is coming out every minute. Coming out. What math are we talking about? Hoping you're talking about subtraction. It's going to go down. So we're going to start with the 266, and we're going to lose 9.5 gallons every minute. And that's how easy it is to write the function rule. We're going to make a table of values, and I am just, again, for practice, going to show you the table, but I'm going to show it going not down, but horizontally, because oftentimes books like to do it that way, or you could see a table somewhere, and I just want to make sure that you can turn that thinking. So I'm going to put my minutes on the top, and I'm going to put my gallons on the bottom, and I'm going to start with 0 minutes. That's going to give me, when I put 0 in, that's my start amount. And then my numbers of gallons should be going down. So what happens, I'm going to do 5, I'm going to do 10, I'm going to do every 5 minutes to kind of see what's going on here. So now I go to the calculator, and I take 260 minus 9.5 times 5. It equals, there's 218.5 gallons left in the tub after 5 minutes. Now input 10, 260 minus 9.5 times 10. There's 171 gallons left, and keep going. Is this data discrete or continuous? As the water leaves the tub, which one is it? And I'm hoping you said this time continuous. It's a measurement. So as the minutes go by, the gallons don't jump. Like, it goes through every level. So this one we definitely would connect with a line. I'm going to leave this here because you're going to get ready to do a graph with me for this one, but I want to make sure that you have the table written down and everything that's here. So I'm going to wait a minute, and then we will make a graph. If those of you that are waiting, we're going to make a graph. We're going to have just a Y and an X axis. Not going to have quadrants 2, 3, and 4. There's no negative things going on here. It's just going to be quadrant 1. And we're going to start labeling, putting a title, our labels, and all of that. Now, if for some reason at any point I go forward and you need, please pull it back and pause it if you need to, okay? All right, so let's make our graph, guys. You got a Y-axis and an X-axis, and let's start by putting our title and our labels. So a title, what would be a good title for this one? Hot tub draining? That sounds good to me. Now remember that your X and Y, that's where we define our variables right here, minutes and gallons left in the tub, right? So X is going to be our minutes, and y is going to be the gallons. And this should really say left in the tub. It's not the gallons leaving, it's the gallons left. So let me, just so for lack of confusion, let me just put that, okay? Alrighty, now we need to figure out what we're going to put for our scale. This is the hardest part. Once we do this, it's plotting points. So I'm going to go back, and I need to get up to 20 minutes, and I need to get up to 266 gallons, okay? So I'm looking at that. So 20 minutes, and I think if I go by, I was going to say, did I go by twos? It looks like I went, so I'm 2, 4, 6, 8, 10. I am. Yeah, I was hoping I was going by twos. 12, 14, 16, 18, 20. Now, you can write the 2, the 4, the 6, the 8 in if that helps you to plot things correctly. Sometimes you get so many numbers in here, it's hard to see. But every 5 blocks is 10, so every block is 2 minutes. Now, remember, I had to get up to that 266. Really, I want to get up to 300. So in order to do that, I am doing 20, 40, 60, 80, 100. And then another 20, 40, 60, 80, 200. And another 20, 40, 60, 80, 300. Again, if you need to write 220, 240, 260, 280, you can do that. And I'm going to stop here for a second and make sure that we are good before we go back and plot our points. You can't hear it, but now I've got the dog behind me snoring. I don't think you can hear him. It's crazy working from home. Alrighty, so now we're going to go and remember that we're going to plot these points. So we're going to plot 0, 266, 5, 28, about 219, 220, right? And we're going to plot these 1, 2, 3, 4, 5 points. So I'm going to ask you to plot your 5 points, and they should relatively fall in a line. Now, this time you're not starting at 0, 0. You're starting at 0, 220, 240, 266. So the dot is going to be right about where my arrow is. And then what you're going to notice is this time your points are going to plot and you're going down because the water in the tub is going out. So your gallons are going down. So don't be surprised. Plot your points, and then we'll draw our, I'm going to say line, and we'll talk more about that in a second. Oops, went right flying by it. Sorry about that. So there are my 1, 2, 3, 4, 5 points basically in a straight line. And then I connected. Now this definitely is connected. It's a continuous. We're not doing it just to make predictions. It definitely should have the line. But what you're going to notice is I did not put an arrow out here because you aren't going to go into negative time and you're not going to go above the 266. And down here, you're also going to notice there's no arrow because that would mean that you were like going into negative gallons. So that wouldn't happen as well. So what we want to do is use the graph at this point to find the time required to fully drain the tub. What is that question asking? It's asking when there are how many gallons would be in the tub if it was drained. And I'm hoping you said 0, right? So we want 0 gallons, which is your Y. And we're going to come out here. And right here, that is the point, which is about, it looks like a little bit, about 28 minutes, because this would be 20, 22, 24, 26, about 28 minutes is when, the tub would be fully drained. So I'm hoping that these 2 examples helped you guys to, just get a feel for it so that you can now practice. Let me stop presenting. So what I'm hoping is now you can go ahead and you're going to do 3. So it's the same thing we've been doing, except now you have to write the rule, define your variables, make a table, make a good graph, title, labels, good scales, plot your points, connect and extend depending on, what the information is, and then make some predictions, answer some questions. So I hope this helped you get ready. I'm going to stop now and let you get to work. Have a great day, everybody. Miss you guys.